This lesson is about expanding binomials to powers. Our objective is to use the binomial theorem to expand binomials to powers. What I want you to do is see that when we look at binomials to a power, like x plus y squared or x plus y cubed, x plus y to the fourth power, this is the result that we get. But how do we get there? To multiply it out would take quite some time. So let me demonstrate that to you. And then we're going to look to see if we can shorten that process a little bit. So if we look at x plus y to the fourth power, which will result in this, we look at the fact that you write out x plus y 4 times. If you multiply x plus y times x plus y, you get x squared plus xy, that's 2xy, plus y squared. So that's this result for the first two. And if you multiply the second two, you get the same result. So now I've got to multiply these two trinomials to get what x plus y to the fourth power is. So let me go ahead and multiply this out by hand and see what we get. So x squared times x squared is x to the fourth. X squared times 2xy is 2x cubed y. And then x squared times y squared is x squared y squared. Now let's multiply 2xy times each one of these. 2xy times x squared is going to be 2x cubed y times, there's just the y there. And then we're going to go ahead and take 2xy times 2xy, that's going to be 4x squared y squared. And then 2xy times the y squared is going to be 2xy cubed. And now let's go ahead and take the y squared times each three of those to distribute through. So we're going to have y squared times x squared is x squared y squared. Y squared times 2xy is 2xy cubed. And lastly, y squared times y squared is y to the fourth. So now let's combine like terms. So this one here is going to be the same. I've got another one right here. And when I combine those, I'm going to get x to the fourth plus 4x cubed y's. And then I'm going to have, here's an x squared y squared. Here's another x squared y squared. Here's another one. So 1 plus 4 plus 1 gives me 6x squared y squared. And then I've got these here, the xy cubed terms, x squared xy cubed. This one here with this one here combined gives me 4 of them, xy cubed. And then lastly, we've got our y to the fourth. So that gives me the result here that I was looking for if we multiplied it out by hand. But hopefully what we can do is look for a pattern that can shorten that process. Well, to do that, I want to look at the coefficients of these. If we get rid of the x's and y's and just look at the coefficients, a pattern emerges. So if we start out with just x plus y, that's 1 and 1 here. So we'll start off with just x in the top, and then x plus y is 1 and 1. Then we've got 1, 2, 1 here. The next one is 1, 3, 3, 1. What we can start noticing is that the pattern is that the first one and the last one are always 1. And then if you look, if you add these two, you get this one. Add these two, you get this one. They fill in the gap in the next row by adding those terms. So what I should get here, if I look at it, I'm going to have a 1 out here, then add 1 and 3, you get a 4. 3 and 3, you get a 6. 3 and 1, you get a 4, and then you just end off with the 1. So notice those are the coefficients of each of these terms. So the next one in this row, if I had x plus y to the fifth, should be 1, add 1 and 4, you get 5. 4 and 6, you get 10. 6 and 4, you get 10. 4 and 1, you get 5, and then you get a 1 out here. So the pattern continues all the way down. If you use that pattern, you could go down and get the next row from the previous row. Now what I'm going to look at here is, if that's the case, look at what's happening with the exponents on the x's and y's. The exponents here, let's look at this one. It's x as a 3, a 2, a 1, and then none. it's going down from the highest exponent down to no exponents. Here we have no y's, and then it goes up to 1, 2, and then 3. So it goes up. So the first one goes down, the second one goes up. What I want to do is use that, for instance, to look at expanding this without having to go through this whole process of multiplying it out 5 times. Let's use this row here, that is the row that has the 5th power in it, and let's expand it. So what it will look like is I'm going to go with 1 and as my first coefficient, then I'm going to take the 2x to the 5th, and then I'm going to add to it the next one, 5, and I'm going to have 2x to the 4th, and then times the second term, 3 to the 1st. So it starts going up in value. And then I do the next one, which is 10. I'm going to do times 2x to the 3rd power. It's going 5, 4, 3. And then I'm going to do 3 to the 2nd power. And now I'm going to do the next one, which is going to be another 10 times 2x to the, in this case, it's going to be the 2nd power, times 3 to the 3rd. It goes up in power. And then let's go plus 5. It's going to be times 2x to the 1st power, times 3 to the 4th. And then lastly, we'll have a 1 as the coefficient. And then the 2x is 5, 4, 3, 2, 1. No more 2x's. And then I'm going to have the 3's go none. 1, 2, 3, 4. And now it will be up to the 5th power. And now I just have to simplify these coefficients. Okay, so this will be 2 to the 5th. 2 to the 5th is equal to 32. And then I have x to the 5th times the 1. Plus 2 to the 4th is equal to 16. 16 times 5, that's going to give me an 80. X to the 4th. Oh, we're going to take that 80 though, and we're going to multiply it by the 3. So we're going to have 80 times 3 is 240. X to the 4th. Plus, now we're going to do 2 to the 3rd, that's 8. Times 3 squared, that's 72, times 10 is 720, x to the 3rd from that, plus 2 squared is 4, 3 to the 3rd is 27, so I'm going to take, and I'm going to multiply 4 times 27, and then I'm going to multiply that 27 times the 10, and I get 1080. This will be x squared. And then I'm going to do 2 times 3 to the 4th. 3 to the 4th, it's going to be 81. 81 times the 2. And then I'm going to multiply that by the 5. So get all those numbers multiplied. That's 810. X to the 1st. And then lastly, 2 to the 5th is equal to 243. So that's my expansion of 2x plus 3 to the 5th power. Gives me this value. Okay. All right, now if I'm doing a problem like this one, okay, I'm going to do the work for it above the previous one. So we're going to do this one above here. So I'm going to take it, and for number 2, and I'm going to expand it out using the 4th row here. So I'm going to take, and I'm going to have 1 times 5x to the 4th plus 4 times 5x to the 3rd. It's going to go down in power, and now we introduce the negative 2. Make sure you include the negative to the 1st. Then plus 6 times 5x to the 2nd power times negative 2 to the second. Then plus, I'm going to have a 4 here, times 5x to the first, times negative 2 cubed, and then plus the last one's going to be my 1 times, and I'm going to have negative 2 to the 4th power here. Okay, now I'm going to take these and simplify each one of them. So the first thing I'll do is just simplify. I want 5 to the 4th power. So 5 to the 4th power is going to be 625. So 625 x to the 4th plus, now I'm going to put the plus in there, but let's go ahead and erase it because I'm going to have a negative. Negative 2 is to the 1st power, so that negative is going to come through. So I'm going to do 4 times 125, which is 5 to the 3rd, times 2. And then I've got a negative. That gives me 1,000. And we have x to the 3rd. And then plus, now this one's going to be 6 times 5 squared is 25. Times negative 2 to the squared is going to be a positive 4. That gives me 600 x squared. Then minus, because we have a negative cubed here, we'll end up having a negative. So 4 times 5 times my negative 2 to the 3rd will be negative 8. That gives me 160. And that'll be x. And then lastly, negative 2 to the 4th is going to be a positive, and that gives me positive 16. So that's this one expanded out for 5x minus 2 to the 4th power. So what we have is if we want to expand binomials, we can do it the long way where you just write it out each time and keep multiplying. But there is a shortcut using what's called Pascal's triangle, and binomial theorem is a pattern. And that means we're going to expand it out using these as the coefficients, and then have the first term start out at the highest exponent. If it's to the 5th power, start out the 5th, and go all the way down to no exponents, so a 0 power. And then the other factor, the 3 in this case, start out with none of them, and then go all the way up to the 5th power by the end. And if we simplify those, which takes a bit of time, but we can get that long polynomial simplified quicker by using the binomial theorem.